Hello young people, here's the second video, diving into Unit 2.3, the rock cycle. I gotta tell you guys, when I was in college, I got my major in geology because I got really excited by geology. And part of that was getting really excited by rocks and minerals. And rocks and minerals might seem boring at first, but they get really exciting when you realize that the Earth has been writing its own autobiography for all 4.6 billion years of its history. The Earth has been writing its autobiography, and there are so many stories written in there. And how are those stories written? They are written in the rocks and the minerals. And geology is the study of how to read those stories that are written in the rocks and minerals. And once I figured that out, and once I figured out that there's a lifetime and more of stories to be told, if only you have the patience to read the way they're written, man, I was hooked. I love geology so much. So 2.3 is all about the rock cycle. Rocks seem really stable, you know? They seem like they don't change, really. But they do. They change over vast time scales, thousands to millions of years. So what we're going to do is go over what 2.3 talks about, which is just some basic stuff about rock properties and different types of rocks. Remember, this is the vocabulary. This is the alphabet of the Earth's autobiography. So, geologists and other scientists categorize rocks based on various properties. And those properties of the rocks are what tell the stories. Some of those properties might be the color of the rock, the texture of the rock, how the minerals fit together, what the minerals are, how big the minerals are, the shape of them, the composition. These are all things that help tell a story in a rock. For starters, this will take you all the way back to like 4th grade or whenever you learned this. Scientists and geologists categorize rocks in 3 basic families. And those families are divided up based on the way the rock formed. And you've heard them before: igneous, sedimentary, and metamorphic. Quick definition for each one of these. Igneous. An igneous rock, the simplest way to explain it, is a rock that formed from cooled magma. Magma is melted rock, and if we cool it, we will turn it into solid rock. And any melted or any cooled magma is going to be an igneous rock. Next up, sedimentary. Sedimentary rocks are made from sediment. And sediment is just little bits and pieces of other stuff. So, quite simply, a sedimentary rock is a bunch of other stuff cemented together into a rock. Talk more about it in a little bit. Finally, metamorphic rocks. Metamorphic rocks, that simply is a rock that started as a different type of rock and was changed by some kind of natural process involving high temperature and high pressure. Now, the rock cycle that our book is talking about, the rock cycle involves different types of rocks turning into other different types of rocks. And in some cases, that could be a rock turning into a metamorphic rock, like I just said. But it doesn't have to be. The rock cycle is a bigger system than just turning one kind of rock into a metamorphic rock with high temperature and pressure. So, for example, it all starts with magma, liquid rock, and that magma is going to cool. Now, it could cool slowly or quickly. It could cool underground or at the surface. But somehow, if that cooled magma, which makes what kind of rock? Igneous, cools, after a little while, if it's exposed to the elements, if it's exposed to nature, it's going to start to weather and erode. And when it weathers, it's going to break into smaller pieces. So our igneous rock, it's breaking up, it's going away. What's it turning into? It's turning into sediment. Well, Now, if that sediment all gets concentrated somewhere and somehow is cemented together, now we've gone from an igneous rock to a sedimentary rock. Or let's say that igneous rock gets buried really, really deep and it's under a lot of pressure. It might turn directly into a metamorphic rock. Sedimentary rocks can do the same thing. If we take a sedimentary rock and bury it and expose it to high temperature and high pressure, we can turn those things into metamorphic rocks as well. And finally, sedimentary and metamorphic rocks, if we get them hot enough, they're going to melt and turn back into magma. And then when that magma cools, they'll be igneous rocks again. So all this to show you, the rock cycle is bigger than simply the process of metamorphism. But I want to point out the many ways that water plays a part in the rock cycle. Water erodes existing rocks. Water takes that sediment and transports it. Water sorts that sediment out by size. When the water's high energy, it can transport heavy stuff, and as the water slows down, the heaviest stuff drops out first. So further upstream, you're going to get bigger rocks. And as you get downstream and the water slows down, you're going to get smaller and smaller rocks. Water sorts that. Water can also precipitate minerals. Just like if you've ever poured yourself a glass of water and left it somewhere and forgot about it, and you came back and it was all dried, but there's a little thin layer of white stuff on the bottom. Those are minerals that were in the rocks. They were in the water. It was dissolved in the water until the water evaporated and the mineral was left over. And finally, water. We're talking about the role of water in the rock cycle. Water causes melting of rocks. At depth, when you're deep enough, if you introduce water into that high temperature, high pressure system, it triggers the minerals down there to melt, and it starts turning rock into magma. So, that's the rock cycle and sedimentary rocks. Well, that's the rock cycle. Next up is sedimentary rocks. We'll see you there.